Yeah, I'm super excited to be giving this talk with all you ML practitioners here. As Anupama said, I've been working in trust and safety for the last 5 years. I've been leading the MSN, I led the MSN Trust and Safety org, and now I lead trust and safety for Facebook app, the entity and actor integrity specifically at Meta. So yeah, let's dive in. And I'm looking forward to all the interesting discussions and questions. Okay, so I think this set of screens are going to be very familiar to a lot of you folks, where across social media sites, this you might have seen cases where you don't actually, you're not expecting to see these, and this is when you click on the 3 dots that appears on top of the post or comments, you will be able to report the content. And this is and I picked the flows from Twitter, Facebook, and Google, for example. And as you can see, there's like multiple different types of violations that you could be reporting here, and there are multiple categories and subcategories ranging from very severe harms to more prevalent but less severe ones. Yeah, so if you look at the category of harms, there's a wide range, starting with, disclaimer before, I should have said this before, this is a content moderation talk, so disclaimer about sensitive topics and sensitive content in here. And another disclaimer is these are not exactly the ones that are in MSN or Microsoft or Meta. This is more a study of the content moderation field across social media and the technology that's used across companies. So there's no direct reference to any of the internal systems. But generally across social media companies, these traits range, what we call as traits or violation types, range from very, very high severe things like child abuse, human trafficking, drugs, etc., to nudity, violence, gore, which are still severe, but not as severe as the first set of categories, to more prevalent but less severe ones like clickbait, spam, which actually causes very bad user experience, but not necessarily like the extremely severe cases that we talked about. And there's a whole range of these and subcategories within each of these that every company has a whole taxonomy of these what we call violation types or traits. And if you can see here, with AI evolution, LLMs becoming mainstream, we've also seen evolution of new types of things that are coming up, such as deepfakes, which are extremely hard to find out, and hallucinations, so which adds on to what goes in the bucket of misinformation or disinformation, one of the hardest classes of content moderation traits for detection. We'll talk a little bit more about how the general trust and safety system itself works. A brief primer on that is every social media company has large investments on trust and safety to ensure user safety and their own brand safety. And this is a multidisciplinary domain. This is very unique in this domain, that unlike other fields where it's predominantly product and engineering, there is a huge policy and legal presence who define what is allowed, what is not allowed for the brand. And there is also the operations component, or the human operations component, which is doing the content moderation day in, day out. We also use them for labeling, expert label judgments that are used to train the models, that are used to evaluate the models. We'll talk more about that as we go, but this is a unique space that's a multidisciplinary domain across product, operations, policy, and legal. And if you look at one layer beneath it, you also see that this is multidimensional, in that there is a content type violation, actor type violation, behavioral violations. Like the content by itself may be benign, but in spam cases, it's just distributed across multiple surfaces that it becomes spammy. So the behavior is the one that you want to moderate there. So, and within each of these, there are multiple categories, as I said, from adult, gory, child safety, hate speech, misinformation, profanity, just name the very common ones. And each of these then go into text, image, videos, audio, short form comments, long form articles, reels, etc. And if we look at measurements, there are multiple different ways in which these are moderated, and depending upon the method of moderation, like whether this is proactive moderation, reactive moderation, or appeals, there are different metrics for each part of the system, and we'll go a little bit deeper into that. This is what happens behind the scenes in a content moderation system in a very simplified form. It's definitely more complex than this when it comes to all the different dimensions that we talked about. But firstly, this you can see my pointer here. The first one is, like, as the content is ingested into the platform, we have proactive moderation systems that checks against the policies. And this is where you have the models that are the first layer, which are passing through all of this content and deciding whether this is policy violating or not with high confidence. And if the confidence level or precision is pretty high, then it decides to auto enforce, and enforcement here could mean remove the content, demote the content, or warn the users, etc. Or it can decide to say, hey, this is benign content, I'm just not going to do anything about it, and then it gets published, for example, in your social media sites. So this is what happens when you are creating a post or creating an article, for example, in the proactive system. And then the reactive, this is the user reports, which is where the users are reporting the against certain violation types, and this goes through the reactive moderation pipeline. It's a very similar one where it goes through, the models are checking whether this content is okay or not, and it's taking down, it decides whether to take down or not. But if it is not confident in both of the proactive and reactive cases, it gets escalated to human reviewer systems. And this is where what we call a scaled human rated ops, or low cost vendors who are able to do this at scale are employed, and they take a decision by checking against the policy whether this is violating, and they decide to take it down or not. And this is the third part of the system, which is appeals. Let's say a decision to take it down has happened, then the creator of the post or comment is notified, hey, your content is violating this policy, and then it's taken down. But it might have been a false decision, or they think that this is false, and they can appeal, and it goes to the appeal actioning platform, which usually, there could be models here as well, but for simplicity, these usually go to human raters who are rating whether this decision can be overturned or not. And then this part of the system is the enforcement, and this part of the system is measurement. And although we have the enforcement, it's very, very critical for us to have a measurement platform to say how much bad content is actually prevalent in these systems. And how we do this, how companies do this is they sample users or content, whatever we are measuring, sample a set of that of the content from production, send it to again human raters, because that's where we think the accuracy is higher. We'll talk about that more, and we send it to high quality expert raters. This one is important because we are using this measurement is really what defines where your product's prevalence is, the violations prevalences, and hence you need to make sure that the quality of this labels is super high quality. Your product decisions are based on it, the shipment decisions are based on it, and whether you're going to invest in this or not is going to be based on this. So we really need to have high quality decisions in here, and usually these are higher quality tiered raters called expert raters, and they decide whether this is policy violating or not, and that goes into the metric reports to determine prevalence, which is a proxy for recall, to say how much percentage of the content in my production system is actually violating. And then the counter metric, which is precision, which says, hey, for the decisions that are taken down, how good is that? What is that precision? Okay. So, and what are the challenges with this system? I think this problem is one of the main problems here. It is a needle in a haystack. You have very, very low prevalence for these traits. So if, let's say, there's like there's millions of content that's getting into the social media networks, and less than, depending upon the trait, of course, some of the very severe traits can be very, very less than less than 1%, less than 0.1% even. But still, given the severity of these, it's very, very important for us to identify and remove them. And that makes this problem very, very hard because, as you can imagine, with millions of content, you're trying to find this one piece of content or very, very small number of content that's violating. And as like all social media sites, the scale and volume is pretty huge. And for each of the content, as I mentioned above, you have to check against multiple different traits, multiple languages, multiple modalities, and content, active behavior, etc. So it really bloats up very, very quickly. And there are always constant emerging threats. This set of hierarchy of traits that I just showed is not fixed. For example, traits like misinformation is always evolving. Misinformation is always evolving based on the current state of affairs, and this is that makes it even very, very complex. And then there's also language and cultural nuances to this. As I said, the high severity misses, even if low volume, can be very costly to the product. Sometimes if you have PR issues, it can even, bring the product to a switching halt because, it can be considered unsafe. There's which warrants a lot of investment in this area. And then so far we've talked about like mitigation of threats, like mitigation of harms to the users who get exposed to it. But there's also the other side of the coin, which is you don't want to overdo it. You want to make sure that you're making these decisions with high precision, so that you're not over moderating, which affects freedom of speech. It can affect livelihood of creators or communities if they are wrongly taken down. This is a very, very important balance. And a hard, challenging one that these large-scale moderation systems have to make sure that they are optimizing both. And then the last one is this is an important one. There's a very, very high dependence on human raters across the enforcement side and the measurement side, making it a very it's expensive. It can also be very inconsistent due to human errors and fatigue, and also slower because of the it takes time for folks to process through this. Well, now coming into the measurement system, as I said, this is important for measuring the prevalence and defect rate. And here it's does not need the scale as much as the scale as enforcement. So because it's a low sample volume from the production traffic. But production systems often need frequent measurements, such as let's say daily or weekly, for us to know where our prevalence and precision metrics are, for ship decisions, for to know where the product is, and for alerting and monitoring. And these need to be consistent and very high quality, which usually the PR requirements for these are about 90%. As mentioned, the low prevalence causes misses. It's expensive, and as I said, this requires expert raters, which we call L3 or L2, L3 raters, and they are usually more expensive compared to the scaled ops raters. And high latency makes the turnaround time. It doesn't allow for near real-time monitoring because of the it takes a couple of days for these ratings to come back. So the general strategy and how LLMs have really helped with efficiency in this is we basically use LLMs for measurement labeling, or majority of the measurement labeling, and use the human experts which is mostly the policy or experts, for tuning or for calibration of the LLMs, so that we are able to optimize for quality, cost, and scale. So here is a modern measurement systems with LLMs. So if you can, I'll try to walk through this one. So we have the fraud traffic. The first step that happens is we upsample, systems upsample positives using cheap, high recall models. The reason we say high recall models is that, as I said, it's a needle in a haystack. So we want to make sure that it captures most of the defects that are prevalent, because measurement systems can't afford to miss them. So use cheap models to get most of the violations, even if the precision is low. And then you send it through a high recall, high precision, more expensive LLM model grader, which gives the results, the final labels in most of the cases. But you can also, I mean, some of these measurement systems can stop right here, but in some of the cases, you can also have a confidence to these judgments to say, hey, is this high confidence? Does LLM think that this is a high confidence judgment? And if not, you can escalate it to expert labelers. And in this case, majority of the volume is handled by the stage, and only the medium low confidence cases goes to expert labelers, and then transformation pipelines are there to put that as metrics in your dashboards. I think the place where now it shifts from this entire 3 steps being done by, entire volume being done by human raters, to majority being done by LLM graders, and now the human raters being more used for QA testing of the LLM grader. So this is where we use a very, very small sample. Previously, we used to have like very large data sets for training models. You need very, very small sample, a couple of hundreds is sufficient, of positives and negatives that are rated by policy experts, which are like in-house policy experts who are writing these policy guidelines. And so they know in and out of these guidelines and can have very, very high quality, because the scale of the ratings that we need is very less. It is sufficient to get very less labels, but with very high quality from the policy experts. And they then grade this LLM model, and this LLM model is tuned with those policy labels to get very, very high quality models, LLM models that are then can be used for this large scale measurement rating. So this really shifts the cost from, or doesn't shift, it really saves the cost from a lot of expert raters to just a very small number of ratings coming from policy, and also gives the lift in quality. Previously, we used to, systems take a lot of time to get very high quality, and it's also consistency is very hard to maintain over time. And if you degrade, you go and debug these. Now with these systems, it's very very quick to scale across markets, get labels very quickly. The need for human raters have shifted from scaled raters to more of policy and expert raters. And the general principle here is create a labeling funnel with cheap models at the top, but more expensive models or humans at the bottom. So we can get more efficient there. I think I covered most of this. Like some things that I want to write right here. The best models now are nearly as good as humans, having higher consistency, lower cost, latency, and agility. The model choice is very important, and the prompt itself weighs heavily into the accuracy. And these prompts need to be tuned with very high quality ops data sets and rigorous prompt tuning techniques. So we'll talk more about the prompt tuning techniques at the end. Models and humans make mistakes, but different types of mistakes. So error analysis by policy experts is crucial. And given measurement is crucial, it's also important to have continuous way for us to keep an eye on the LLMs that are used for measurement so that you don't have blind spots. And the other practical difficulties that comes with this is like with rapid model advancements, these measurements are also continuously shifting. So it's very important to have vetted expert data sets and rapid auto-tuning techniques so that when a model migration happens, it's very, very easy and quick to change your measurement system and rebaseline. And as I said, human raters is changing from scaled rater needs to knowledgeable expert policy raters. Enforcement systems, very similar, but the difference is the scale. Scale of enforcement systems is much larger than for measurement systems. Measurement systems, the scale is small, the quality is high. For enforcement systems, the scale is large, so we really need to optimize for cheaper models. And it is impossible, at least like large social media size, it's impossible to use LLMs for each single decision that comes through, and hence this is where the LLMs are more used for training data collection and measurements for grounding, and then training of smaller scale models more quickly than before with higher quality training data that we get from the LLMs. This is a flow how previously, whenever we need to train models for the automation layer, we'll have to wait for expert labels, and usually this requires lots of expert labels and hence delays, or you have to settle for scaled ops labels which are lower quality and hence garbage in, garbage out. You'll be struggling with data cleaning and data collection, which is the heavy weight of the process. But now how this efficiency is achieved now is you have the SMEs who are writing the policy guidelines, who gave us very small set of SME labels, just a couple hundreds of positives, negatives, depending upon the trade, of course. And then this is used to tune the LLM prompt, GPT, or any large model, which the one that you can afford, and tune the prompt, and then pass in your unlabeled data set. This can be a large volume of unlabeled data set that you want to use for training data. And then this LLM creates a labeled data set, which because this is tuned with respect to expert raters, then this is now able to replicate that quality to get large amount of training data that is then used to train your small language models using distillation techniques. So this really speeds up the agility of the process, and the quality of this data set that you're able to get in large volumes really increases the quality of this output model as well. This is how the enforcement systems have evolved now. With fraud traffic, you have the cheaper SLM distill models for auto decision, and the low confidence cases. And this is again a multi-tiered system. For the SLM decides in most of the cases, but in cases where it decides that this is low confidence, it can have escalation scenarios where it can escalate to the LLMs or VLMs, and it's basically an optimizations story where we decide like, hey, how much can you afford to send to this versus how much is the precision and recall bar that you need for this particular trade, and that decides how much we are auto decisioning versus sending to LLM. And then the next tier of escalation can also be, hey, let's say this is also not super confident, and or these are high priority cases where you cannot afford to make mistakes. You always want human oversight. Then you send it to expert labelers as a third layer. But as you can see, the volume of things that goes to labelers also decreases a lot because of the higher quality that you're able to get in these two layers now. And then the actioning happens. And as I said, like previously before, these models are actually, the development is similar. You take a small sample, policy experts, labels, get the prompt tuned, get large data set, and train the model. This really helps with getting smaller models for inference, large scale inference, and it increases the automation rates to decrease the human rater dependence. Takeaways, I think one question many may ask is like, why not use LLMs in the enforcement stack? As I said, if your system is not too large to scale and you can afford that, I think that makes sense to use the same in the enforcement stack. But one thing to be careful is the LLMs model they don't come with confidence scores, and so for product needs you might have to tune that to have higher precision in some cases or higher recall in some cases, and so that becomes hard. Capacity constraints and higher latency of larger models compared to the smaller models. General principle, as I said, use expensive models for measurement data collection, cheaper ones for large scale enforcement, and close the gap with distillation techniques, which can get very close. How am I doing on time? Okay, so there are some prompt tuning techniques. I think this can be shared, like zero shot, few shot, dynamic example selection. This is I'll just talk through this one example. For example, in the clickbait system, you can choose even in few shot, you can dynamically choose what examples to put in your prompt to get better quality. This has really helped with some of the quality. And another one that I wanted to introduce is auto-tuning agents, which have been super useful given the number of dimensions and number of trades. We really need to be very agile with prompt tuning and development, and auto-tuner really helps to get these prompts really quickly with policy and expert trainers. We have the prompt generation agent, evaluation agent, and an error analysis agent that tells us like what are the cases where the previous prompt is not doing well, feeds it into it. So it fixes that in the next iteration. And then you get the best prompt out. So this is also kind of automated. So you remove the engineering effort that's needed for tuning. So I'll stop there. There's many other cases where it's used in trust and safety systems like explainability, assistance for human rater decisions, drafting agents, etc. But I think I kind of completed most of it. So
amazing. Thank you so much, Madhu. I think that was amazing. That was so insightful. Thank you so much for taking us through the behind the scenes and how the collaboration works. We quickly have about 3 questions. One is from Amit Mittal. So he's asking, what evaluation loop do you use to maintain precision and recall targets over time? Do LLMs generate continuous measurements while human experts audit the drift and recalibrate the thresholds?
Yes. So if you look at the measurement pipeline that I showed, we do use the measurement, or systems do use the measurement measurement pipelines based on LLMs for continuous evaluation. So these are sampled daily, weekly, and sent to these LLM models that are calibrated with human raters. And on a less frequent basis, the human experts are used to see if there is a drift or to see whether there are blind spots and retune the LLM. So that's exactly right. These are used for continuous measurement.
Awesome. The next question is, can you walk me through your multi-tier moderation stack? And how do you route between the cheap, high recall models, expensive LLMs, and the expert reviewers? And what telemetry do you collect? Do you use to collect the monitor drift latency and the cost?
Yeah. So the way these are done, like for example, the cheap models to LLMs and expert is you're looking at the precision recall and really determining what is the confidence levels for each of these models, and this is more of an optimization of how much resources that you have at the next year versus the overall precision recall that you want. And so really for the cheaper models, and it's easy to get your tune these thresholds so that you can see, hey, how much volume of escalation you're optimizing between how much do I need to escalate versus how much overall quality do I need to decide how much goes into the next layer. Sorry, can you repeat the second part of the question?
So the next question is, what telemetry do you use to collect the monitor drift latency and the cost?
Yeah, what telemetry to monitor
the drift of the models and latency.
Yeah, this is where I think, like, for the measurement systems to monitor the drift, we also have like human rater pipelines, but at much lesser frequency that are running. And usually these are, let's say the LLM based measurement is saying a certain precision recall, and the human rater is saying a certain precision recall. Usually they are aligned, and let's say there is a spike in either, then you're going in to investigate. Then sometimes it can even be the human rater quality that's actually dipping, not really the LLM. But it's important to investigate those to find out where the gap in the systems are. For latency, I think this is just like decision latency. I'm not sure if there's more to the question, but there's instrumentation around like, hey, when the content comes in to when this is auto decisioned, and that is the time. And there are with stricter latencies that also influences what types of models that you're choosing. I can happy to answer in the comments or in the app later too.
Absolutely. Yeah, I think those were the 2 questions from Amit, and then we have one last question. I'm not sure how to interpret this, but what are the expensive models do you use? I'm not sure. Maybe
so the expensive models, like, I mean, these systems have GPT-4 was used, and then I think it started off with GPT-3, 3.5, 4, and then in VLMs just 4.0. And these are used mainly for escalation layers. But I think it really depends upon what, and also open source models are fair game, like, Llama models that can, as long as you have the capacity to host them and do the inferencing, I think everything is, it really depends upon what works better for your particular traits and gives the best performance on your expert data sets.
Awesome. Thank you so much, Madhu. And we do have one more question. I'm not sure if we have enough time. The last question is, do you see a lot of variance between the results of different LLM models? And I think we have like about a minute. Oh, no.
Yeah, definitely. And I think I mentioned this, like with models very quickly evolving, it's very, I mean, it's common that companies will get like, hey, there's a new model, we're going to deprecate the old model because they can't host both of them at the same time. And so you have like very strict deadlines by which you have to migrate the, measurement and enforcement systems, and they don't work off the bat, which is why it's important to have very buttoned up expert judgments where you can very quickly evaluate. I think agility is the key. Very quickly evaluate, and then the auto tuning agent, for example, the one that I shared at the end of the deck, is also a means where we can very quickly tune the prompt to this data set based on how the model performs. And yes, definitely, as models progress, we do see that the errors that are made between the models also differ. Well, usually it gets better, but there are cases where you need to tune.